Hello, today's Unit 3 is Lesson 11. So if you will turn in your books to here, page 115. So this starts page 115. You'll see that today the target is for you to understand that multiplying each side of an equation by a factor, by a number, it could be a fraction, regular number, it creates equivalent equations, meaning same equation whose graph and solutions are the same. So we're going to look at that, how multiplying doesn't change the equation solution, it only changes the look of the equation. And then I can solve equations by multiplying each side of one or both by a factor, then adding and subtracting to eliminate a variable. So today we're doing solving systems by elimination again. This is part 2, because now we're going to have to multiply those equations like we did at the end of the last lesson. So if you will look there on page 115 at the warm-up, consider these two equations. So 4x plus y equals 1, x plus 2y equals 9. Use a graphing technology to graph the equations and find the solutions. So in Desmos is the best thing. I have that pulled up here. So when you go to Desmos, just the regular graphing calculator, remember you can just type in the equation. So the first one was 4x plus 1 or plus y equals 1. So that red line is that equation, 4x plus y equals 1. The other one is x plus 2y, x plus 2y equals 9. So that's the blue line. Blue line is, and where those two intersect is the actual solution to that. So you can plug these in, find the intersection. There's your x, there's your y. So -1, 5. So here, using the graphing technology, the answer is going to be -1, 5, or if x is -1, y is 5. All right, so anytime you need to solve, but if you're not capable, if you're not allowed to use the graphing calculator, we have to do other methods. So in part 2 of the warm-up, it says write the equation that are equivalent to equation A. And remember, equation A is 4x plus y equals 1. That's equation A. By multiplying both sides by the same number. For example, 2 or -5. So let's just use their example. So it says in A1, do multiply both sides. So if you have 4x plus y equals 1, you're going to multiply both sides by 2. Don't multiply different numbers on both sides. That would not be equal. But you can multiply the same number on both sides. So you can distribute the 2. That would be 8x plus 2 times y is 2y equals 2 times 1 is 2. So this equation is equivalent to that original equation. If you did it with -5, 4x plus y equals 1, multiply the left side by -5, multiply the right side. So as long as you multiply by the same number, you will get -20x minus 5y. If you did plus a -5, that's fine. Equals, remember this is multiply, not subtract, so -5. This equation is also equivalent to those. So here it says use your graphing technology to make a couple observations about those. So if we go back to Desmos, I'm going to get rid of this second equation. So there's my 4x plus y equals 1. when we multiplied it by 2, we got 8x plus 2y equals 2. You'll see that that green line just covered up the red line. If I take away the green, you'll see the red. Those are the same equations, right? They are equivalent. And you know they're equivalent on a graph when one is right on top of the other. The A2 was negative 20x minus 5y equals negative 5. And again, that purple is right on top of the green, that's right on top of the red, right? The purple, they are all the exact same line because they're, and if I did another number, if I multiplied the top one times 3, 3 times 4 would be 12x plus 3y equals 3 times 1 is 3. And you're going to get another one. So no matter what, as long as you multiply the left side and the right side by the same number, you're not changing the line. You're just changing the coefficients and the constant, but you're keeping it all equivalent. All right, so back to, so here, make a couple of observations about your graph. You can write in what you just observed. You know, they are the same line. They have the same y-intercept, same x-intercept. All right, so let's look at activity 1. Activity 1 has, here is a system. So this is the one we just had, same system of equations. We solved it by graphing. We already know that the solution was, go back, right, negative 1, 5. We know that that's going to be the solution. And that's your x, that's your y. So to start the system equation, Elena wrote the original one, 4x plus y equals 1. She then did 4x plus y equals 1, and the bottom equation changed to 4x plus 8y equals 36. We had that, right? What's she doing to go from this? She has taken, oh, we didn't have this one because we didn't change the bottom one. What is she doing? What is she multiplying on both sides to get 4x plus 8y equals 36? Hopefully you're saying to yourself 4. 4 on both sides, right? Because 4 times x, 4 times 2, 4 times 9 is 36. And that way she is making the x's have the same coefficient. Well, once you have two equations that have the same coefficient for x or y, you can add or subtract. If they're both positive, you want to subtract. So now Elena is going to subtract them. 4x minus 4x, 0. 1y minus 8y is negative 7y. 1 minus 36 is negative 35. And stopped right there. Well, if we took it one step further, right, we would know why negative 35 divided by negative 7, negative divided by negative is positive 5. And we know that's right. So Elena did everything right. So what were her first two moves? Her first move was multiply the second equation, right? She multiplied the second one, the B equation. Multiply, let's not say second, the B equation by 4. Second step was then subtracted the equations. So first she multiplied by 4 to get those x's the same, then she subtracted. All right, so now complete that solving process. So you saw, so we know that it was negative 7y equals negative 35. We also know that the original equations are 4x plus y equals 1 and x plus 2y equals 9. So now show, without the graphing calculator, how can she get those two solutions? And we already went to 5. Try that. Pause and try that. So if you tried it, you should have divided by -7 so that you got y equals 5. Then that 5 has to substitute back into one of these. And I'm just going to do the top one, which is 4x plus y, which is 5, equals 1. And then solve that one. Subtract 5, subtract 5. 4x equals -4. 1 minus 5, -4. Divide by 4. X will equal -1. There you have both of them. All right. So in this, what do you notice? What do you wonder? Go ahead and pause and fill out what do you notice about these? What do you wonder about those? And then when you unpause, I'm not gonna write anything down. It's what you notice and what you wonder. This is up to you. What I notice is these two, the black line, which is the 4x plus 1, and the blue line, those are the two lines that we graphed at the beginning. And we found that intersection, which is -1, 5. We know that point. And then when she subtracted the two equations, this is the equation she got. And when she graphs it, it goes right through that point. And actually, if you graphed x equals -1, which is what x equals, that would be a vertical line also right through that point. So every equation, every equivalent equation, they would be the same line, but anything after adding and subtracting them is going to create an equation that still goes through that point. All right. All right, so moving on, turn the page. So we are now on page 118. And read the information. Write a system of equations representing the constraints for this one. Remember, you're using C for calculators and M for measuring tape. Go ahead and pause and try to write that information. Okay, hopefully you've tried that and you've unpaused. So C is the cost of one calculator. So if you bought 20 calculators, you would multiply them by how much they cost. So that's the cost of 20 calculators, and plus you bought 10 measuring tapes. That would be the cost of 10 measuring tapes. The total price you paid is $495. So that should be one of your equations. She placed an order she didn't have enough, so she did another order. Same calculators, same measuring tape, but this time she got 8 calculators. And I'm going to go ahead and 1 measuring tape. And this time she paid $178.50. So this is called, it's a system of equations because it consists of 2 different equations, 2 different variables, and with that we can figure out what the cost of the calculators and the cost of measuring tape. Remember from the lesson we did at the beginning with just graphing that if we only had one equation there would be a lot of different possibilities. But once you get 2 different ones, then you can look at the intersection. So now, moving on to part 2, solve the system without graphing. So without graphing, again, we have 20m plus, 20, So we have 20C, 20 calculators, and 10 measuring tapes equaled 200 or 400. Ooh, $495. And then she bought 8 calculators and 1 measuring tape, and that cost $178.50. So if we're gonna, without graphing, we can use this elimination we're talking about. And to do that elimination, we are gonna have to get the coefficients, the 20 and the 8, to be the same with multiplication, or the coefficients for the m's, the 10 and the 1. Now, if you look at 20 and 8, the first number that they both go into would be 80. You could multiply the top one by 4, the bottom one by 10, and that's going to make 80 for both of them. Or you come here and do the second one. The 10 and the 1, all you have to do is multiply the bottom one by 10. Right? So you can choose either one of them, but you have to multiply. Remember, you multiply everything, both sides, by the same number. Really should be both sides of the equation. So I'm going to use the 10 and the 1. So I'm going to multiply the bottom one by 10, the top one by 1. So go ahead, pause, and see if you can get those new equations from that. All right, so 1 times 20 would be 20C, plus 1 times 10 is 10M, equals 1 times 495, right? You want to multiply 1 on both sides, and 10. That's still 495. Multiplying 10, 10 times 8 would be 80, plus 10 times 1 is 10, equals 10 times 178.50 is actually 1785.0. And so now you have two equations so that they do. So we can eliminate the m's because they're both 10 and they're both positive. So I'm going to eliminate them with subtraction. So if you didn't get the first step, go ahead and get the first step right now. Subtract these two equations and see if you can solve for C. Pause and try it. All right, so when you did 20 minus 80, you got negative 60. C. 10 minus 10 would eliminate. And then 495 minus 1785. Might need your calculator. 495 minus 1785 gives you a negative 1290. And then divide by negative 60. C is 21.5. So now you know C. I'm going to come back to one of my original equations. I'm going to use the bottom one because the numbers are smaller. That's a calculator. I'm going to substitute in. So if 8C plus 1M equals 178.50, and C is 21.5, substitute it in for your C. Multiply 8 times 21.5 is 172, plus 1m equals 178.50. Subtract 172. So 1 measuring tape equals 650. Divide by 1, it stays the same. So a measuring tape is 6.5, or since we're talking money, calculator, measuring tape. So what does the solution mean in the situation? It means that a calculator cost, because C was the cost of a calculator, $21.50. So calculator cost $21.50, and a measuring tape cost $6.50. One of each, right? All right. So let's look at activity 3. So here was Diego's problem. This is how Diego solved. So go ahead and pause and describe the moves that he created to make the equivalent. All right, so copy down the problem, right? Same thing. Here, the bottom equation does not change, so he's changing the top one. So we know he's multiplying. And 6 became 12, 5 became 10, -7. So he's multiplying by, hopefully you said 2, right? Multiplied 2 on both sides. Then that created a +10 and a -10. So since they're opposite signs, he's going to add the two equations together. So describe, he multiplied first equation by 2 and then added the two equations together. Yeah, so he multiplied the top equation by 2 and then took the new equation and added it to the second one. All right, write another equivalent system different than Diego's that will allow one variable to be eliminated, enabling you to solve the original. Be prepared to describe. So let's take Diego's original, 6x plus 5y equals -7, and 2x minus 10y equals -14. So what they're saying is instead of multiplying the top one by 2 and making the y's both 10, this time multiply a different number, and you can even multiply one on top, one on bottom if you want, and match up the x's or the y's in a different way. So try that. See if you can solve. Now what I choose might be different than you, as long as you did it mathematically correct. So since the first time Diego made these both 10, I'm going to look at the x's, and I'm going to make the x's, looks like I could make the bottom equation easily match the top one. I can make that 2 into 6 by multiplying by 3 on both sides. So I'm not going to change the first equation. The bottom equation would become 6x minus 30y equals -42. And then what would I do to eliminate the x's? I'd have to, since they're both +6, subtract the two equations. 6 minus 6, 0. 5 minus -30, remember that becomes a plus, so 5 plus 30 would be 35. Y equals -7 minus -42. -7 minus -42 is a +35 also. So I know y is 1. divide by 35, y is 1, and then you can plug it back into either of them. So I'll do the top one, 6x plus 5, y is 1 equals negative 7. 6x plus 5 times 1 is 5, negative 7. Subtract 5, 6x equals negative 12. Divide the 6, x equals negative 2. So we got x, y. Now if we go back, to Diego's, when he ended up here, negative 28 divided by 14, he would have ended up with x equals negative 2. If he plugs that back in, 6x is negative 2 plus 5y equals negative 7. Negative 12 plus 5y equals negative 7. Add 12 to both sides. 5y equals 5. Divide by 5. And you end up with the same. So it doesn't matter which order as long as you keep the math correct. Negative 2 and 1. Negative 2 and 1. Use your equivalent system, then check your solution. That's exactly what I did with number 2. So we went all the way to the end, but we know that it's negative 2, 1. If we use Diego's method or the method I showed you, doesn't matter. All right, so you should have an assignment that is from lesson 11. So have a great day.